Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. Apollo 12, the next giant leap in lunar exploration. On November 14, 1969, a lightning bolt struck a rocket on its way to the moon. Yes, you heard that right, lightning hit Apollo 12. Just moments after liftoff, the rocket encountered a thunderstorm, with lightning flashing all around. The entire launch site shook, and people on the ground held their breath, fearing the mission might be over before it even started. But what about the astronauts? Not even a hint of panic. They kept their cool, and with a casual attitude, handled the unexpected technical glitch. "No problem, we've got backup," they said, and continued their steady climb to the moon. This didn't stop humanity's march into space. Apollo 12 wasn't just any space mission. It was our second close encounter with the moon. Thanks to precision technology, Apollo 12 successfully landed on the moon, marking a leap forward in both technology and space exploration. Behind this mission wasn't just cutting-edge technology, but also three astronauts with incredible personalities. Their stories made this historic flight even more remarkable. Let's take a moment to talk about these astronauts and their journeys before and after the moon landing. Pete Conrad, the commander of Apollo 12, may not be a household name, but once you hear his famous line on the moon, "Hey, Earth, don't worry, I'm in Antarctica," you'll definitely smile. That humorous remark wasn't just for laughs, it showed Conrad's calmness and sense of humor while facing the strange and dangerous environment of the moon. His relaxed attitude on the lunar surface earned him the title of the funny guy among astronauts. But Conrad's sense of humor wasn't just for the moon. His adventurous spirit had been clear since his youth. Born on June 2, 1930, Conrad joined the U.S. Navy, becoming a fighter pilot. During the Korean War, he participated in several combat missions, and his flying skills earned widespread recognition. He became legendary in the aviation world, especially after pulling off a nearly impossible maneuver in an F-4 Phantom jet, making him a legend in flight circles. During his naval service, he took on several high-risk flights and earned multiple awards for his bravery. In 1963, Conrad was selected as a NASA astronaut, marking the start of his journey into space exploration. On the Apollo 12 mission, he led the team to successfully land on the moon. Not only did he complete complex tasks, but he also conducted scientific experiments and collected lunar samples alongside Alan Bean. Conrad even sent the first batch of data from the moon back to Earth, laying the groundwork for future lunar missions. Despite his illustrious space career, Conrad's life was filled with adventure. He was always curious about new things and even insisted on touching the moon's rocks himself to ensure the accuracy of his experiments. His space career didn't stop after the Apollo 12 mission. In 1973, he became the commander of the Skylab space station program, executing the first U.S. space station mission. Conrad's journey came to an unexpected end on October 8, 1999, when he passed away in a motorcycle accident at 69. Then there's Alan Bean, the lunar module pilot of Apollo 12, who became the second person to walk on the moon. When Bean and Conrad stepped onto the lunar surface, they didn't just carry out scientific tasks, they also made lasting memories. Bean recalled, "The moon was so quiet that you could hear your own breath." At that moment, like Conrad, Bean experienced a feeling of unparalleled achievement. But that wasn't all. Alan Bean's talent went beyond space exploration. He was also an artist. Before his time with NASA, Bean studied aeronautical engineering at a university in Texas, then joined the U.S. Navy as a fighter pilot. His excellent flying skills got him selected as an astronaut in 1963, and he immediately began his rigorous training. But unlike other astronauts, Bean wasn't just about flying, he was a brilliant artist. His lunar paintings have since become iconic in space art. His experiences on the moon directly influenced his artistic work, as he used his brush to recreate the lunar landscape. Bean even used materials from his spacesuit to make his paintings, attempting to capture the moon's true essence. Bean's artistic journey began after he retired in 1981. He dedicated himself to creating space-related artworks, bringing his moon experiences to life on canvas. His pieces are highly regarded in the space community, and many are now housed in space museums and private collections around the world. Bean passed away in 2018 at the age of 86, but his art continues to be a cherished part of space history. One of Bean's fun stories was when, before the Apollo 12 mission, his wife joked, "If you make it to the moon, I'll give you a painting." After the mission, Bean brought her a piece of moon rock as a gift and quipped, "This rock is worth more than any painting." Richard Gordon, the command module pilot of Apollo 12, didn't set foot on the moon himself, but his role in the mission was absolutely crucial. Born on October 5, 1929, in California, Gordon had a passion for flying from a young age. After graduating from college, he joined the U.S. Navy and quickly became a pilot. Gordon's flying career wasn't just confined to the Navy, he also became a test pilot, excelling in various flight test programs. In 1963, Gordon was selected by NASA to become an astronaut, marking the start of his journey into space exploration. During Apollo 12, Gordon was responsible for commanding the command module, ensuring the safety of the flight. His job was to ensure Apollo 12 successfully entered lunar orbit and that the astronauts could safely return to Earth. Gordon once humorously mentioned in an interview that, although he didn't land on the moon, he was the closest guy to the moon in space. Gordon's flying skills were top-notch, and he played a key role in several critical missions, especially during the later stages of the Apollo 13 mission, where his technical support was crucial. In 1973, Gordon became the commander of the Skylab space station program, leading America's first space station mission. After retiring, Gordon continued to contribute to space exploration, serving as a consultant on multiple projects. He also held executive positions at several airlines, continuing to give back to the aviation industry. Gordon passed away in 2017 at the age of 88, marking the end of an era for space pioneers. Now, let's move on to our main focus today, Apollo 12. Apollo 12 wasn't just about replicating the success of Apollo 11, it aimed to do better. On November 14, 1969, the mighty roar of the Saturn V rocket engines filled the air as a massive trail of flame shot up into the sky. In that very moment, humanity's second mission to the moon had begun. Along for the ride were the three astronauts we just introduced, ready to take on this new challenge. But hold on, don't get too excited just yet, because the next few minutes were filled with twists and drama. Just 36 seconds after liftoff, the rocket was hit by lightning. Yes, you heard that right, lightning struck the rocket's side. We all know launching a rocket is a highly precise task, and a thunderstorm is definitely not part of the plan. Saturn V, this colossal rocket, was struck by lightning, and for a split second, the astronauts' hearts must have skipped a beat. But do you know what their reaction was? "We need to restore the systems." That's right, the astronauts on board acted like it was just another minor electrical glitch. True astronauts. Pete Conrad and Richard Gordon quickly switched to backup power systems and continued their journey. And even more surprisingly, the control center on the ground didn't panic either, because they knew everything was under control. But Apollo 12 wasn't just a simple moon landing. Its mission required a much more precise landing, and the target was the Surveyor 3 area on the moon, just 163 kilometers away from the Apollo 11 landing site. Think about it, if Apollo 11 had a landing error of several hundred kilometers, Apollo 12 had to hit a target only 163 kilometers away. This wasn't just a lunar exploration, it was a huge leap in space technology. It was a massive leap forward for the tech at the time. Next, the astronauts were probably thinking, now we can finally get to work. But it wasn't that simple. The lunar activities of Apollo 12 were far from easy. They had to complete a series of complex experiments and sample collection tasks on the lunar surface. Pete Conrad and Alan Bean didn't just collect moon rocks, they also installed a laser reflector to help scientists measure the precise distance between Earth and the moon. This tiny device is still in use today, helping scientists with ongoing lunar research. When Pete Conrad first stepped onto the moon, his sense of humor showed up once again. He said to the camera on Earth, "Hey, this place looks just like Antarctica." His light-hearted remark perfectly reflected Conrad's calm and humor in the face of the unknown. After all, who would have thought that two astronauts in bulky spacesuits, standing on the moon, could joke so casually? But Apollo 12's astronauts were not just tech experts, they were also the first moon comedians. Take Alan Bean, for example. Like Conrad, he had the ability to find light moments even in the most serious tasks. On the moon, Alan Bean wasn't just conducting lunar exploration, he was also a lunar photographer. During the Apollo 12 mission, Bean not only carried out sampling tasks but also took tons of photos of the lunar surface. To him, this desolate, silent planet wasn't just a place for scientific experiments, it was a canvas for artistic inspiration. In fact, Bean later became a renowned space-themed artist, and his lunar paintings are now treasured by museums and private collectors worldwide. Apollo 12's astronauts weren't just explorers, they were pioneers in scientific experimentation. For example, during the Apollo 12 mission, the astronauts brought back over 34 kilograms of lunar rock samples, which provided invaluable scientific data that laid the foundation for future lunar exploration. By studying these rocks, scientists were able to learn more about the moon's composition, structure, and its relationship to Earth. Richard Gordon, the command module pilot of Apollo 12, though he didn't step foot on the moon, played a key role in the mission. Gordon was responsible for commanding the command module, ensuring that the astronauts could safely return to Earth after completing their lunar tasks. During the moon landing, Gordon stayed calm and performed all the necessary operations on the command module, staying in constant communication with the ground control center to ensure everything went smoothly. You can imagine, with millions of kilometers of space between them, each communication between the astronauts and the ground was a critical conversation. They had to make sure all the data was accurate and that every system was functioning perfectly. At this point, many people might think, well, Apollo 12 sounds like a pretty smooth trip to the moon. But it wasn't all sunshine and rainbows. The moon's environment isn't as friendly as we imagine. The astronauts faced extreme temperature fluctuations on the surface during the day. The temperature could reach 127 degrees Celsius, and at night, it would plummet to minus 173 degrees Celsius. They weren't just astronauts, they were extreme survivalists in space. And despite the challenges, the success of Apollo 12 demonstrated the power of human courage and resilience. Despite lightning strikes, technical failures, and the harsh conditions of the lunar environment, the astronauts stayed focused and completed their mission. Especially after the lightning storm, many were concerned the mission would be called off. Who would have thought that the astronauts, like superheroes, could stay calm even after handling the electrical glitch and continuing their flight? Their ability to stay cool under pressure is truly an astronaut's superpower. But even so, Apollo 12's success didn't come without a few hurdles. Although the landing site was only 163 kilometers from the target, it was still a big test for both the astronauts and the ground control center. They had to precisely control their trajectory and land accurately. If they made even the slightest error, the mission could have failed. So, Apollo 12's success wasn't just about technology, it was a product of human ingenuity and determination. Once they landed, the astronauts immediately got to work. You might think, did they just stroll around, taking pictures, playing space tourists? Haha, no. They were busy, real busy. As soon as they landed, they started setting up the laser reflector, conducting geological surveys, and collecting lunar samples. Every task was directly related to Earth's future scientific research. Pete Conrad and Alan Bean were like research scientists and super pilots all rolled into one. Their first task was to install a device called the Lunar Laser Reflector, which would help scientists measure the precise distance between Earth and the Moon using laser beams. It might look like a small device, but the science behind it is anything but simple. Apollo 12's astronauts had to place it precisely on the lunar surface so that laser beams would reflect back to Earth. Today, scientists are still using this device to measure the Earth-Moon distance with an error margin of just a few millimeters. It's a long-lasting tool for astronomers to study the Moon's movement, Earth-Moon gravitational interactions, and whether the Moon is slowly drifting away from Earth. This task, though simple in appearance, was full of challenges. The Moon's surface temperature varies drastically, with daytime temperatures reaching 127 degrees Celsius and nighttime temperatures dropping to -173 degrees Celsius. These extreme fluctuations made their task even more difficult. And with almost no atmosphere to shield them, the sun's radiation was directly hitting the Moon's surface, adding complexity and danger to the operation. But Conrad and Bean didn't just rely on their technical skills, they worked meticulously to ensure everything was done perfectly. Next, Apollo 12's astronauts carried out a critical lunar geological survey. This wasn't just a tourist stop, it was a task that would provide scientists with invaluable lunar data. Apollo 12's landing site, the Surveyor 3 region, was 163 kilometers from Apollo 11's landing site. It was here that Conrad and Bean collected rock and soil samples, especially from areas near the Surveyor 3 spacecraft, which had landed on the Moon in 1967. This probe provided guidance for Apollo 12's mission. Using Surveyor 3's data, the astronauts pinpointed their landing site and working area. Apollo 12's astronauts brought back 34 kilograms of lunar soil and rock samples, including some fairly large rock chunks. These pieces are now housed in museums, serving as priceless artifacts from the history of lunar exploration. During sample collection, Conrad and Bean also conducted a scientific experiment: lunar photography. They took a lot of photos of the Moon's surface, capturing different types of rocks, geological formations, and lunar features. These photos didn't just provide vital data for scientific research at the time, they'd become priceless resources for future lunar missions. Their busy lunar activities lasted a total of 7 hours, during which Conrad and Bean completed scientific tasks, thoroughly checked the laser reflector and other equipment, and made sure everything was in working order. Apollo 12's success highlighted the importance of precise landing and scientific experimentation. It's worth noting that although Richard Gordon didn't step foot on the Moon, his role was just as important. As the command module pilot, Gordon ensured that the astronauts would safely return to Earth after completing their lunar activities. Apollo 12 wasn't just a testament to the astronauts' courage and skill, it also showcased the critical importance of teamwork. Throughout the mission, Gordon stayed in close contact with mission control, ensuring that every detail of the flight was flawless. After the astronauts returned to the command module, their mission wasn't over, not by a long shot. In fact, the lunar surface activities were just part of Apollo 12's mission. There were still several days of spaceflight and the precise recovery process to complete. They needed to bring back all the scientific data and samples, ensuring these priceless findings made it safely back to Earth. The entire mission lasted 10 days, from November 14 to November 24. Over those 10 days, Apollo 12's astronauts navigated the complex process from launch to landing, even facing lightning strikes and system failures. And when they successfully completed the mission and returned to the command module, everyone let out a collective sigh of relief. At that point, Apollo 12 had met all of its scientific goals. The astronauts had successfully collected 34 kilograms of lunar rocks and soil samples, installed the laser reflector, conducted detailed geological surveys, and completed lunar photography. These tasks didn't just provide crucial data for scientists, they also offered valuable lessons for future lunar missions. Back in the command module, the astronauts spent hours on instrument checks, sample storage, and data input, ensuring everything was properly secured. Despite the monumental tasks, the astronauts maintained a high level of efficiency, never slacking off. They knew that every step they took was now a part of human history in lunar exploration. Imagine how exciting it must have been when the Apollo 12 astronauts were ready to leave the Moon, heading back to Earth. They had completed their precision mission, surpassed Apollo 11's achievement, and demonstrated a higher level of human space exploration. But maybe, just maybe, as they made their way home, they were thinking, can we do this again? After all, landing on the Moon wasn't just a scientific task, it was a human adventure at its limits. For the astronauts, even though the mission had made history, they might have still harbored dreams of going back. Maybe, like us, they were imagining a future where they'd once again cross space and set foot on that moonlit, mysterious land. When Apollo 12 successfully returned, the astronauts' work wasn't done. They had to complete a series of re-entry procedures to ensure the command module could safely re-enter Earth's atmosphere. One of the toughest parts of a lunar mission is how to safely return from lunar orbit to Earth. Apollo 12's astronauts relied on precise navigation and close coordination with mission control, achieving this feat with flying colors. On November 24, 1969, Apollo 12 successfully splashed down in the Pacific Ocean. After hitting the water, the astronauts were quickly recovered by a Navy rescue team. Despite all the challenges, they had completed their mission, setting a benchmark for future space exploration. Apollo 12 was far more than just a regular moon mission. It went far beyond the single goal of landing on the moon. It symbolized humanity's fearless pursuit of science and the unknown. It wasn't just a perfect continuation of Apollo 11's success but also the foundation for even greater breakthroughs in U.S. space endeavors. Looking back on Apollo 12's journey, we can see its massive contributions to space exploration. It didn't just leave footprints on the moon, it left an everlasting mark on the history of space exploration. One of Apollo 12's most significant contributions was its precise landing. On November 19, 1969, Apollo 12 successfully landed in the Moon Surveyor 3 area, exactly 163 kilometers from Apollo 11's landing site. This wasn't just an advancement in flight technology, it was a revolution in spacecraft control systems and navigation technology. To land with such precision, NASA developed highly accurate navigation and landing systems, including the Laser Guidance System and Lunar Module. These systems played a critical role during Apollo 12, proving that spacecraft technology could be accurate to the millimeter and handle complex external environments to ensure astronaut safety. Apart from the precision landing, another highlight of Apollo 12 was its scientific experiments. One of the most well-known was the installation of the Lunar Laser Reflector. This small device is still in use today, reflecting laser signals sent from Earth to measure the precise distance between Earth and the Moon. The system remains a vital tool in ongoing research, allowing scientists to measure this distance with millimeter-level precision. Its installation boosted lunar distance measuring technology and provided long-term data support for future space missions. Additionally, Apollo 12 collected about 34 kilograms of lunar samples, providing valuable data on the Moon's composition, physical properties, and history. Scientists analyzed these samples and confirmed the similarities between Moon soil and Earth soil, further supporting the shared origin theory between Earth and the Moon. These samples became essential research material for global scientific institutions, greatly enhancing our understanding of the Moon's geology, climate, and early evolution. Apollo 12's success wasn't just about precise landing. It laid a strong technological foundation for future space missions. The Saturn V rocket used for Apollo 12 was the largest manned rocket in history, capable of sending astronauts to the Moon thanks to its immense thrust. Apollo 12's successful flight provided invaluable experience for future Apollo missions, especially in managing complex navigation, communication, and flight control systems. Especially during launch, when Apollo 12 was struck by lightning, the astronauts relied on backup systems to restore the rocket's flight, providing crucial emergency handling lessons for future missions. The mission's success showed that astronauts could handle any unexpected events with the right training and contingency plans, proving the reliability and sustainability of space technology. Apollo 12's scientific value wasn't just about the samples it provided but also the roadmap it set for future lunar exploration. The data Apollo 12 provided laid a practical foundation for subsequent NASA missions. For example, Apollo 14, 15, and 16 missions relied on Apollo 12's experiences and results when designing key lunar experiments and selecting equipment. Thanks to Apollo 12's precise landing, sample collection, and laser reflector installation, later missions built upon these achievements, gaining even richer scientific data. Apollo 12 also offered fresh perspectives for lunar geology research. Through detailed analysis of lunar soil and rock samples, scientists were able to better understand the effects of solar wind and cosmic radiation on the Moon's surface, helping them piece together the Moon's history and geological structure. These findings didn't just reveal the Moon's past but also provided crucial clues about the formation of Earth and other celestial bodies. While Apollo 12 was a NASA-led mission, its success also highlighted the importance of international space cooperation. During the mission, NASA maintained close collaborations with research institutions in multiple countries. After the mission, Apollo 12's lunar samples weren't just analyzed in U.S. labs, they were shared with scientists around the world. This international cooperation allowed the data and findings from Apollo 12 to be applied globally, showcasing the spirit of humanity's collective quest to explore space. Moreover, Apollo 12's laser reflector wasn't just a tool for scientific experimentation, it became a symbol of international collaboration among astronomers. Since its installation, observatories and research institutions worldwide have used it for astronomical studies, promoting global cooperation and scientific exchange. That small facility on the Moon became a crucial symbol of international space research collaboration, paving the way for future technological innovation and deep space exploration. Apollo 12's success also pushed forward technology for deep space exploration. Through laser reflection on the Moon's surface, sample collection, and other activities, NASA didn't just gather precious technical experience, they also provided crucial technological support for future missions, including Mars and Venus exploration. For instance, the laser reflector installed by Apollo 12 became a key tool for precise positioning in future planetary missions. Following Apollo 12, NASA developed more space exploration technologies, including enhanced navigation systems, more durable spacecraft equipment, and efficient communication technologies, all of which continue to be used in modern deep space missions. Looking back, Apollo 12 wasn't just about leaving footprints on the Moon, it left an indelible mark on the history of space exploration. From precision landing and scientific experiments to technological innovation, Apollo 12's legacy continues to influence future space exploration. Its success wasn't just a milestone for U.S. space achievements, it was an important step forward in global space technology. The astronauts of Apollo 12, with their courage, wisdom, and humor, created one of the brightest chapters in human history. Whether it's their precision techniques or the invaluable data they brought to the scientific community, Apollo 12 made unforgettable contributions to lunar exploration, space research, and international cooperation. Today, when we talk about human lunar landings and deep space exploration, Apollo 12's legacy remains deeply etched in our minds. The people who changed the world. Usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.